Well, it may be that the
This
geometric horizon is nearer still, but the point is, if you had a geometric horizon, let's just say at 2 miles, just for the sake of argument, and the ship is 3 miles away and half hidden, or would be half hidden, with the amount of refraction on that day, it may lift it up a bit, but not all the way, so you can see the whole thing. So some of it is
but the
hidden
point is what the
by
point
the
is
apparent
what is
horizon.
hiding those. What the horizon is hiding it. So a non-physical thing is blocking something.
No, it's hidden behind the water, but there's not enough refraction to lift the image of the full ship above that apparent horizon.
Craig, do you want in on this? Because is this your image? K values?
Well, this is just something that it explains about why the horizon can be looming. I'm not getting involved. I'm just putting this up for reference for everybody that's watching.
If it's all right with Mr. Sensible, you can have your opinion on this too.
Yeah, I'm fine. I'd appreciate some input. Yeah.
Oh, my position is that the horizon most of the time is apparent, unless the K value matches what the curve of the Earth is. Then you will be seeing the geometric horizon. I mean, but that is obviously depending on the lapse rate and the coefficient of refraction. My personal opinion is you see things go over the apparent horizon.
Always. Do you ever see it go over the geometric horizon?
You would see that if the K value matched the curve of the Earth. In that specific instance, you would then see the geometric and the apparent horizon would be the same. But obviously, depending on the coefficient of refraction, the apparent horizon can shift. I mean, as this graph says, there's times where if the K value is below 1, so -1 or -2, then the horizon can actually appear as though it's concave, which has been demonstrated in my recent debates with a few concave earthers. So, yeah, the apparent position of the horizon can change quite a lot, but that is what we see. We see the apparent horizon unless the K value matches what the curve of the Earth is, then we will also see the geometric horizon. But obviously that is very specific circumstances.
Yeah, I'll just say you never see the geometric horizon. Therefore, in the black
you're
swan
asserting
image,
it because you're saying there isn't one.
because there isn't one, the black swan image proves that, because horizons cannot be loomed up above horizons. Is that what you're asserting here, Craig? That the horizon is being moved up above the horizon?
In certain conditions, yeah. When there were some researchers that were doing these observations around the Antarctic Circle, and the K value was actually about -16, and it literally made it look like, they were on halo and it was rising up in the distance. So the horizon, the geometric horizon, is still a physical thing. So I don't know if that would be excluded from things looming. The horizon is still a thing. So I would say that the horizon can also be loomed because it's a physical thing. That's what the apparent position is. But this isn't my debate, and I don't want to get into it. I would love you two to have this conversation. Mitchell, you and I can definitely have a conversation on another day, because I've studied the maths of this quite a lot.